what's called a hole in our graph. We'll find the x and y intercepts of our graph, find all the asymptotes, and then, unfortunately, since we can't use graphing calculators this year, we'll have to plug in some points to get test points for this. So, make sure. In class, obviously, I don't care if you're using the graphing calculator, but you don't get it on the test or quiz, so make sure you're following my process and not just relying on your calculator or Desmos to help you, because it's not going to help you in the end. We need to know how to do this stuff. A hole in our graph happens when something cancels. If I had x squared minus 9 over x plus 3, x squared minus 9 would factor using difference of squares, x minus 3, x plus 3. Once we factor that, then we can see the x plus 3 on top and bottom will cancel out. And just leave us with x minus 3. So when that happens, there is a hole, an empty circle in the graph, at, and then we'll have to be able to find the ordered pair. The x value of the ordered pair comes from the thing that canceled. What makes x plus 3 equal 0? Negative 3. So that's the x value. To get your y, you plug negative 3 into what's left. So once I cancel, I'm left with x minus 3. If I put in negative 3 for my x, negative 3 minus 3 is negative 6. So what this tells me is when I graph this thing, negative 3, negative 6 is going to be an open circle on this graph. And then to finish the graph, you would just graph what's left, x minus 3, this one is just a line, y-intercept of negative 3, slope of 1. So the final graph looks like this. Your graphing calculator will not show you the holes. It automatically reduces your equation before graphing, so you have to be able to find those by hand. So now we're just going to start graphing our rational functions. We probably won't do any today that have holes in them, but tomorrow we should, in our 23 minutes, we should be able to get to some. So if I look at this one, first step is factor, whatever you can. You can't do anything with the negative 1. What about x squared plus 4x plus 4? Does anything cancel? No, so there is no hole on our graph. Then we can find x-intercept. We said Tuesday an x-intercept is where it hits the x-axis, so y is equal to 0. If you set this whole equation equal to 0, and you had to solve it, the first thing you would do is multiply by the denominator, right? When you multiply that denominator over 0 times anything is 0. So an x-intercept every time, it's really just looking at what makes the numerator equal 0. What will make the top of the fraction 0, because every time you'll multiply over the denominator. Does negative 1 equal 0? No. So there is no x-intercept on this one. Y-intercept is where you hit the y-axis, so that means x is 0. So we put in 0 for x. It does not matter if you do the original or the factor, you get the same thing. So the top is negative 1, bottom will give me 4. So I hit my y-axis and negative 1 for it. Then we do asymptotes. where do you find vertical asymptotes? You're doing right. Vertical asymptote is what makes the bottom 0. That's part of why we factored it. So now it's easy to see what makes x plus 2 equal 0. -2. So my vertical is at x equals -2. And the other one gives me the same thing. Multiplicities don't make a difference on this. So I don't have to say it has a multiplicity of 2. My asymptote is a vertical line that we are not crossing. So we draw it as a dashed line at -2. Then we have horizontal and oblique. So we kind of talked Friday, or it seems like Friday, Tuesday, about how to find these. We generalized a few rules, but I told you if you forget, all you really have to do is divide. Can you do -1 divided by x squared plus 4x plus 4? If you do -1 divided by x squared, does that give me anything? No. It's because the power of the top is smaller than the bottom. If you have fewer x's on top, we can't divide them. So my horizontal is y equals 0. And that's why we didn't have an x-intercept, because the x-axis is a horizontal asymptote. These graphs, they're always curved, approaching our asymptotes. So over here, we're going to have 2 sections, one on each side of the vertical asymptote. My options are, it might either be above this horizontal one, or it might be below. And it's just going to be a curve approaching those asymptotes. The only way to figure out above or below is to do what? Plug in some values of x and see. We don't need to do a lot. So if I just put in, let's say, this is at -2. Let's put in a -3. So we're just doing a test point here. You can use your calculator to plug it in. You put -3 into your original equation or your factor form, it shouldn't matter. What do we get out? -1. So -3, -1. So is this above or below? Below. That's all I needed. On these, I am not checking if you have all your points correct. I want your asymptotes in the right spot. I want your intercepts in the right spot. And then our test point is just to see where this section of the graph falls. So I know -3, -1 is the point on my graph. And so then I have a curve. It's approaching my asymptotes, getting closer and closer. Make sure you are careful with this. I always have somebody that wants to draw something like this. Is this approaching my asymptote? No, it curved away at the end. It's not even a function. So be careful when you're drawing those. Then we know it has to be on both the left and the right of the vertical asymptote. We could put in a test point over here, but actually we don't need to because we already know it's down here to hit my y-intercept. So this section, this part just has to be getting closer to our vertical. And this section is getting closer to our horizontal. Now you can certainly use your graphing calculator to double check yourself. If you have one, you can absolutely plug this in. You just need to make sure you put parentheses around the denominator and compare your graphs. And I'm encouraging you to use that to double check yourself. But you should be able to create the graph without a calculator there. What questions do you guys have for me? So that's what we're doing today. We're just going to keep practicing these graphs. So So first step, factor. How can you factor x squared minus 4? And x squared, I'm just going to leave. You can write it as x times x, but there's nothing else we can do. Does anything cancel? No, so we don't have to worry about any holes in our graph. X-intercept. So x-intercept is when y equals 0. So you're setting this whole thing equal to 0. If you multiply over your x squared, fraction is 0 if the numerator is 0. So you're welcome to jump straight to this step if you remember. X-intercept is just what makes the top 0. What's that going to be? On my graph, I hit the x-axis at positive 2 and negative 2. To find the y-intercept. So y-intercept is when x is 0. If I put in 0 for all of my x's, on the top I get negative 4, on the bottom I get 0. Can you do negative 4 divided by 0? No, so there is none. We don't cross the y-axis. Vertical asymptotes. Vertical is what x can't be. It's what makes the bottom 0. It's an equation, so it has to be x equals, and the only thing that makes that 0 is 0. So x equals 0. That's the y-axis. That's why we didn't have a y-intercept. It was an asymptote. Okay, to decide horizontal or oblique, the strategy we learned was dividing. I go back to the original if I do that. So if you think x squared divided by x squared, what do you get? 1. So our horizontal is y equals 1. And if you remember, Tuesday we said, if it's the same degree on the top and bottom, all you really have to do is divide those leading coefficients. X squared and x squared, they're the same. So 1 divided by 1 is 1. So we have a horizontal line of 1. Alright, do I need test points to finish this graph? I know I have 2 sections, one on each side of the vertical asymptote. And my options are, it can either be above or below this horizontal. But I have to go through the point that I already marked, so that means this section has to be below the horizontal line, getting closer to my vertical. And same thing over here, if I'm going to cross that, it has to be below, getting closer to my vertical. And you can always plug in some points if you're not sure. Questions do you guys have for me so far on this? Do you guys understand where I'm getting all of my information and how I know what the graph's looking like? Just keep practicing. Alright, why don't you take a second and see how much of the information you can find on this. So just start going through the list. Looks like everybody got x equals x minus 1 doesn't factor x squared minus 4x plus 2x minus 2. Alright, x-intercept. You can set the whole thing equal to 0. What's the shortcut I told you to find the x-intercept? what part of the fraction has to equal 0? The top, because every time you multiply over the bottom, it goes away. So it's really just when does the numerator equal 0, so that's when the x is 1. So we cross the x-axis at 1. Y-intercept. If x is 0, we can plug it in the original or factored form, it won't matter. So on the top, 0 minus 1 is negative 1, 0 minus 4, negative 4, negative 1 divided by negative 4 is positive 1/4. How many vertical asymptotes do we have? 2. Vertical is what makes the denominator 0. So if we have x plus 2, that means x is negative 2. If x minus 2 equals 0, that's x equals positive 2. So we draw those as dashed lines. Make sure when you're identifying them, they are lines, so you have to give me the whole equation. You have to say x equals. Horizontal and oblique. So if you have kind of caught on to our patterns a little bit, we might be able to tell, if you set up the division, can you do x divided by x squared? No. So what does that mean? It's horizontal, y equals 0. So if the top degree is smaller, it's always y equals 0. If they're the same degree, we're just dividing those leading coefficients. When the top is 1 higher, that's when we saw those oblique asymptotes on Tuesday, where we had to do the long division. Okay, so horizontal asymptote at y equals 0. That might seem kind of concerning because we have a point there, but it's actually okay. Sometimes the middle of your graph might cross over your horizontal or oblique asymptotes. It'll never cross a vertical one, though. All right. Do I know just by looking at this what my graph's going to look like? No. Because I have 2 vertical asymptotes, I have to have 3 sections of the graph. I have to have something over here, something in the middle, and something over here. So if you're not sure, you can always plug in points. So this is negative 2. So if I put in negative 3. Negative 3 minus 1 is negative 4. 9 minus 4 is 5. So when x is negative 3, I'm getting negative 4/5. So that means it is below my horizontal asymptote. My horizontal was at 0. We are below that. So now I know this section has to be here. All right, let's figure out here. If I put in like a negative 1. Negative 1 minus 1 is negative 2. Negative 1 squared is 1. Minus 4 is negative 3. So negative 1 gives me a positive 2/3. So what I'm seeing is this graph has to come up here. So it's just going to keep going up. Right here, it's hitting this. It didn't have a multiplicity, so that means it doesn't bounce, it just has to go through. So it's just going to keep going down. And then if I put in a positive 3, so I'm just picking numbers on every section. 3 minus 1 is 2, 9 minus 4 is 5. So positive 3 gives me a positive 2/5. So I can tell this section now is above my horizontal asymptote. You guys are super quiet today. I'm having a hard time reading you. Do you understand what I'm doing or not? Somebody's gonna have to speak. Like, where are we at? Are we good, okay, or bad? Give me a thumbs. Everybody can do that. Okay. So we're not horrible. I don't see any straight thumbs down, so we just need more practice, I think. Are there any specific questions on this one? How are you guys this tired? You had a day off yesterday. Come on. Let's try this one. Alright, how's the top factor? So again, nothing cancels. X-intercept. Where do I need to look for that? Numerator. What makes this numerator equal 0? So we get -1 and +1. So x-intercept is just what makes the top equal 0. So we hit the x-axis at positive and -1. Y-intercept. That's when x is 0. So you can do it in the factored or the original, it won't matter. 0 minus 1 is -1 over 0. We can't divide by 0, so we have none. Where do we look for the vertical asymptote? The bottom. What makes the bottom equal 0? Just 0. So x equals 0 is my vertical asymptote. So right here. Okay, now we have to decide horizontal or oblique. When I look at this, if we do x squared divided by x, we still have an x left, right? So that means this one's oblique. We have to do the long division. If you need a placeholder, you can put a 0x here. We're just dividing by x. So x squared divided by x gives me just an x. Then you multiply. X times x is x squared. Subtract that off. Those cancel. All I have next is a 0x. 0x divided by x is just 0. So it's just x plus 0. Or we could say y equals x. Okay, oblique is just your normal line. So y equals mx plus b. My y-intercept is 0. My slope is 1, so up 1 over 1. And we have that dashed line. Right. We had one vertical asymptote, so we should have two sections of the graph, the left and the right. On the left, it can either be above my oblique or below, but which one does it have to be? Above. And I don't even have to plug in a point for that because I already have a point here. So I know my graph has to go through that point, and the only option then is if it looks something like this. For the right, it could either be above or below this oblique, but I already have a point below, so it tells me it's going to be down here. And your graph is just approaching your asymptotes on both sides. Should always be a function at the end, so you could check if it passes a vertical line test. I'm going to stop here. You guys aren't saying a whole lot today, so I'm going to give you problems to do, and that way you'll ask me questions and I can figure out what we're having trouble with. So